So it goes all the way back to writing fractions as decimals. How do I take a fraction and write it as a decimal? What do I do to it?
If it's a terminating decimal, you basically, how many spots there is after the decimal, you put, if it's 53, you put it
Hold
over
up.
100.
A fraction into a decimal.
Oh.
You just divide, right? You just divide, okay? Keep your description handy here because you'll be on here. So it doesn't matter if it has a negative like in 13. If we have, don't forget if you have a repeating decimal at the end, just put a little bar over the top that's repeating. So it could be one number, it could be two numbers, it could be three numbers. Just put it over. Something like 14 or 15, again, personally, I would turn that into an improper fraction first and then do your division, or you could just do the fraction and put the whole number on it, right? So 8's got to be in your answer. But any of those, 10 through 15, that you need to see on the board. What do we mean by rational numbers? That's what the next section. We just kind of talked about that again the other day, right? Because we solved equations through rational numbers. So rational numbers means what? Could be any fraction. Decimals that are terminating or repeating, right? Those are the main ones. They talk about now what Alexander was actually trying to spit out the first time, right? So now we're taking and writing a decimal as a fraction. So, Mr. Munoz, you want to try again?
Yeah. How many numbers after the decimal there are is how many zeros. So if there's the point is 0.16, you would put 100 because that's two numbers after zero, and the 100 has two zeros. Then you'd reduce if you can reduce.
I can live with that. Okay. Remember the process when we went through a repeating decimal was a little bit more complicated. Do we need to go through one of those? Yes. Which one do we want to do? 26. All right. So, anybody remember offhand what we did?
You do you write 7. Oh wait. 0.722.
Right? Dot. We set that equal to what?
Equal to n.
Something, right? For whatever reason they used n. And then we have to figure out what?
How many numbers are repeating?
How many numbers were repeating? How many? 2, so that's what spot? The hundreds, and that's what you multiply the entire problem by. I'm going to take that entire thing by 100. And so we end up with 100n is equal to, basically we move it 2 places. 72, 72, 72, okay? Now, you subtract n, because n is this, right? But we subtract n just over here, and then over here, we're basically taking away the decimal part. Oops, I forgot that. So what's 100n divided by n?
99.
99n. And over here, my decimal parts cancel out, so I get 72. Then how do I get n all by itself?
Divide.
Divide by 99. And then last but not least, we should look to what? Reduce. Can I take something out of both 72 and 99? Definitely what? 9. 3, but I'd have to do 3 more than once probably. So 72 divided by 9? 99 divided by 9?
11.
We get a fraction.
I did this wrong. Every time I did this, I did it wrong. So now I figured it out.
Now you got it?
Yeah.
Perfect. Good thing we reviewed that. Any others in that section? Again, don't forget taking a mixed number to an improper fraction. Try to do that as much as possible. We'd rather work with improper fractions than mixed numbers. Okay?
Number 27.
Number 27. Basically, I'm gonna do the same thing. I would just, eliminate that 3 and do the decimal part, and then put that 3 on at the end. That makes sense? 3 would be the whole number, yeah. So I would eliminate that whole number and just do the fob and then put it back on.
So say you have like 3 in your problem, now you just put 3 in the.
3 and 8 11s, yeah. Yeah. You could do it the other way where you're making it an improper fraction and that kind of stuff, but it's just gonna be more complicated. So just throw that whole number out of there. That makes sense? Okay. So, okay with that section? 5.3 was multiplying rational numbers. So here we're looking at multiplying fractions, basically. When you multiply fractions, the first thing we want to look to do is what? Try to reduce what directions? Diagonal or up and down. And then when I actually multiply, I multiply what direction? Straight across. But remember, straight across the top and the bottom. That's the biggest thing that's different between multiplication and addition and subtraction, right? Do I need a common denominator in multiplication?
No.
No, I just do it. So if I don't reduce at the beginning, no big deal. I can multiply straight across, but then I have to probably reduce at the end. So either or, whichever way you pick to do it, make sure you look to see if you can reduce. Okay? So, again, I would turn, like in 36 and 37, our mixed numbers into improper fractions. The other thing is, I see a couple with negatives. Don't forget our rule with negatives and positives, right? If the signs are the same, my answer is positive. If my signs are different, no matter what, they're always negative, okay? And then the variables basically are the exact same thing, right? Like in 38 and 39, we're doing the same process. They just involve variables or letters. So, any of those, 28 through 39? 32. Negative 1 5/6 times 9. Okay, so again, the first thing that I'm going to do is I'm going to turn this into an improper fraction. Remember, when we're doing improper fractions from mixed numbers that are negative, drop the negative. Don't think about the negative when you're doing your process. Then put your negative back on. So what do I get?
11/6.
Negative 11 over 6. Again, I can put that negative on the top or the bottom. It doesn't matter. Okay? And then times 9. And because 9's a whole number, I can always make it into a fraction by putting it over 1. Now I'm ready to what? Reduce. 6 and 9 can be taken out of, or what can be taken out of?
3.
So we get 2 and 3. Now I'm ready to multiply. One negative either on top or on the bottom. Makes the whole thing negative, right? So 11 times 3. 2 times 1. Can I reduce? Questions?
I think add one more, like one half, and then you get negative 17.
Right. Any questions? Any other questions? Any more of those? 38, you betcha. AB over 4 times, what was the other one?
2 over BC.
So, again, basically the exact same thing that we did in the other problem, but now we just have variables. So now we're still looking diagonal to cancel out. So can I cancel anything?
Cross out the 2 B's.
The 2 B's, okay?
And then there's 4 and 2.
2, 4. Again, this is where you got to make sure that you understand what you're crossing out and what you're leaving. So that's kind of how you work with the problem. All right, so what's left on the top? A times 1 or A, and on the bottom? 2C. Remember, we can't just flip-flop our variables wherever we want them. Meaning, just because C started on the bottom, it's got to stay on the bottom. You can't just move it up. Okay? Look to reduce. Again, can't reduce. In all honesty, you should say C cannot be equal to 0, but that's kind of way down the line yet. Any others in that section? So after multiplication, then obviously we tried to divide, and the only difference here was what?
You switch the second fraction.
Keep, change, flip, right? We really cannot divide by fractions. So instead, we keep the first number or fraction. Change means what?
Change it to multiplication.
Turn it to multiplication, and flip means the reciprocal. Taking it and flipping it. Again, the negatives don't really matter. Just keep the negative either on the top or the bottom. Turn everything like 45 still from a mixed number into an improper fraction. And again, the letters don't really bother us. But you cannot reduce before you change and flip. You have to change and flip right away. Okay? Any of these. 40 through 47. 44. 11 over 18. Divided by, help me.
4.5.
Thank you. So, I'm going to turn this 4.5 into what? Which is? 9 over 2. 9/2. So, again, keep, change, turns into multiplication, flip. 2 over 9. So again, look, this was a perfect example. If I try to reduce first, I'm going to distort the answer a lot, aren't I? So make sure you flip before you reduce. Go ahead. 2 and 18. So on the top?
11.
On the bottom? Can I reduce?
I didn't do anything.
You're just making weird noises today. Even weirder than normal. Any others in that section? Keep, change, flip. Don't reduce until you flip. 5.5 and 5.7 basically are adding and subtracting fractions. The most important thing when I'm adding and subtracting any fraction is what? I gotta have a common denominator. Okay? What's the easiest way for me to get a common denominator? Multiply the two denominators together. Why don't we like that sometimes? Yeah. Might have to do some reducing at the end. Still, you might have to reduce no matter what, but if you can try to find the least common, then we're okay. And it's the least common multiple, not the least common factor. Right? So again, if you wanted to find the least common multiple, what would we actually have to do? We could either list them all, but again, that might take us a little while because our list might get really long. Or we do the trees, right? Now again, that's only if you want the least common denominator. I don't think you, in the test, you have to do any of that, like finding the least common. You just have to do the problem. So, 48 through 55, they basically already gave you a common denominator. The ones that still might be a little weird are like 51 and 53 when they have whole numbers or mixed numbers. Again, I would turn them into improper fractions and then just add or subtract the numerators. But again, that's totally up to you. You can try to just do the whole numbers together and then the fractions together, or individually, sorry. And then, but in that case, you might have to borrow, and the borrowing kind of gets a little sketchy sometimes, okay? So, anything on 48 through 51? 71.
For 51, if you didn't do improper fractions and you got the answer, would you want us to turn it into an improper fraction? Or?
Yes. So you would, if you're not going to do it with improper fractions, you would have 1 and 7 over 21, which would turn into 1 and 1/3, which then I would turn into 4/3. Anytime that I can do, or write a mixed number as an improper fraction, I'm going to do that. Because it's going to be way easier to use impropers than mixed numbers down the line. Okay? So Addie wants to see 71. -2 and 1/6.
Plus 5 and 1/3.
5 and 1/3. So again, the first thing that I'm going to do is turn these into improper fractions before I even get a common denominator. So my first one gets what, or turns into what? 13/6, and it's still negative, plus 16 thirds. So, common denominator, 6, right? First thing I would always look at is, can I use one of those numbers that are in my original denominators? And again now, because it's 6, my first fraction just stays the same, -13/6. On the other one, you have to ask yourself, what'd you do to 3 to get to 6? Times 2, so I got to do that on the top also, so I get how much? 32. Now we're back to our rules about adding and subtracting, right? You got to think about all those rules we did way back when. If the signs are the same, we add and use that sign. If the signs are different like this, we actually what? Subtract, and then use the sign from the bigger one, right? And then if it's a minus in between, you can do keep, change, or you can just think about subtraction again. I think a lot of you are to the where you're not doing keep, change anymore. So, what are we going to do for this one? What? 13, basically -13 plus 32 means 32 minus 13. Grace says 19. Is she right? Yep. Over 6. Is it positive or negative? Because 13 is bigger than 32. 32 is bigger than 13. Right? So, see, I've been around you too much too.
Oh, that's not even me.
Can I reduce? Nope. I'm good. Any questions? The rest of those. 48 through 55 or 64 through 71. Turn the page. Measures of central tendency. My 3 things are mean, median, and the mode. The mean means the average, which means perfect. The median, the middle number. I have to make sure that I do what? Smallest to greatest. Some kind of order, right? Smallest to greatest or biggest to smallest. I think I said that right. Did I? Last one. Mode is the most common. Can I have multiple modes? Can I have no mode? Yes. Right? So, do you want to go through one of those? The decimal ones, just take your time, okay? And add them together. I think you guys are pretty good at that. 5, 9, we basically do the exact same thing that we did with solving equations way back when, but now we're just using fractions and decimals. So again, if we don't let you use your calculator, you got to make sure that you get a common denominator if I'm adding or subtracting. But if I'm multiplying and dividing, remember dividing fractions, I'm going to take the reciprocal, and I'm always going to take the reciprocal of the fraction that's with the variable. Decimals, if I'm adding or subtracting, I got to line the decimal point up. If I'm multiplying, then I have to count all the decimal places up and put them in the answer. Okay, so 74 through 77, any of those? Yes, sir? 76. 0.2t equals 6. So, again now, here's a trick to this one right here. How many people really like to divide decimals without a calculator? Probably not a whole lot of us, right? So, watch this. If I looked at this right here, this is in what spot? The 10th spot. I'm going to multiply the whole problem by 10. So, if I multiply 10 by this, I move it over and get 2t. If I take 10 times 6, I get what? 60. Now what? Isn't that a lot easier? So anytime that I have decimals in a problem and I don't have a calculator, I'm going to get rid of the decimal by multiplying by whatever spot it's in. But I got to remember to multiply the entire problem by that number. Make sense? Okay. Now, you could have done it by trying to do 6 divided by 0.2. And then basically we're doing the exact same thing, right? Here's my decimal, it moved one place, so I gotta move this one place. So then we're up here, so how many times does 2 go into 60? It'll be 30. So it's the same exact thing, I'm just trying to simplify the process. Okay? That makes sense? And then obviously the last section is what we did today. Anybody have big problems on that? Arithmetic is if it's adding or subtracting. Geometric is if it's multiplying or dividing. And then we have to find our common difference or common ratio. And then the 3 next terms. Questions? So again, tomorrow's a quiz. Friday will be the test. Tomorrow quiz probably won't take you the whole period, so make sure you bring something to